Well, good evening, everybody. Russ, WI9B. We are going tonight to do the 9th chapter of the ARRL ham radio license course. Boy, I remember it just seems like yesterday when I was telling everybody here that, this is our first night. 9 weeks from now, you'll think it went by so fast, and here it is, 9 weeks already. Normally, we were going to do the test next Thursday night, but since we now have COVID-19 in the county, and since I hate to say lockdown, but anyway, we canceled the test, rescheduled the test until May 3rd, and that'll be at 2 o'clock in the afternoon here at the I Help You, the Study Shop facilities. So this will give everybody a little bit extra time to study. We've had several in the class who have already indicated they feel so comfortable doing the online testing that they are now studying for the general class, and we think that is just totally fantastic. We hope they do. But let's get on with it. Tonight, we are going to be talking all about safety, amateur radio safety, electrical safety, RF safety. We're also going to be talking about radio interference too. So it's a pretty good night tonight. First thing we want to talk about is electrical energies and what the different shocks and burns can do to you. If you've got your ARRL book in front of you, you can go to this graph and see it, but it doesn't take very much to mess with your body. A very low current can actually start causing pain, so you do have to be very careful. Now, nowadays we're really lucky in amateur radio because most of the equipment works off of 12 volts. Unless you get like the big linears or the old tube type radios, they will have high voltages, maybe 400 volts, plus or minus in there. But nowadays it's only 12 volts, so the danger isn't quite as bad as it was in the past. But have enough current to cause really bad problems. We use a lot lower voltage nowadays, like I said, than we did back in the old tube type. The tube type stuff, that could be pretty hazardous when you're playing with it. So the best way for electrical safety, the best thing I can say is you just avoid contact. Is the most efficient way of electrical safety. In other words, if you don't know what you're doing, don't take the case off the radio because you're going to hurt yourself, and it can be really, really bad. If you're going to work on it, you want to unplug the set first. You want to make sure there's no voltage going to it. Even though the radios themselves work on 12 volts, the power supplies take the 110 volts from your wall receptacle, and they reduce it down to 12 volts, but there still is 110 volts on that power supply, so you've got to be very careful with it. Another thing that I've always thought was, it's never going to happen, is you're supposed to keep one hand in your pocket. I've been in electronic repair now since '67, and I have never seen any technician work on equipment with one hand in his pocket. It's just hard to do. You have to have two hands. But that is the safest way. You keep one hand in your pocket. And the reason for that is, of course, if you keep one hand in your pocket, the current, if you actually get into it, it won't have anywhere to go. Where if you had two hands out, your one hand might be on the ground somewhere, and your other hand would hit the positive voltage, and it'll go right through your heart. But anyway, the idea is you're supposed to keep one hand in your pocket. And you're supposed to make sure the equipment is grounded. Virtually all transceivers nowadays, they do have that terminal on the back of the radio that's for ground. That is for a ground wire that you can take to the actual physical ground. Get it safety that way. Another thing for electrical safety is you should use these ground fault protection circuits. You probably recognize them. They're usually in the house, they're usually in the bathrooms and around the kitchens where you're close to water pipes. These have got the two little buttons in the middle, in between the two outlets. One will say test and one will say reset. And that's what these things are for. If you happen to lose the neutral ground or something, it will kick the breaker to shut power off so you don't become the neutral ground in the wires. To mitigate the hazards, to make them less dangerous, and especially if you're working on live equipment, sometimes you have to work on live equipment, you should remove all your jewelry, watches, wedding rings, if you've got any necklaces, you want to remove those. A lot of them are made out of gold, and gold is one of the best conductors you can have. Avoid unintentional touching of circuitry. If you've got an intermittent, a lot of times you'll push around on the circuit board to see if you can make it come or go. That's what they're talking about there. If you've got a radio, one of an old technician trick was if you had a radio that didn't work, you'd turn it on for a while, then you'd turn it off and you'd run your hand over the back of the circuit board and you find out where it's hot at. Usually it was a filter capacitor shorted, and you could quickly locate the shorted filter capacitor just by the touch of the heat it's putting out. Never ever bypass a safety interlock. A safety interlock is basically a little on-off switch that's hooked to the cabinet somewhere. When you take off the cabinet of the radio, it will automatically shut off the power to it. So you never want to do your safety interlocks. A lot of times, and I've seen it around the country in various places that I've been, where a guy will open a drawer, for instance, and he'll stick a pencil down into the interlock to bypass the interlock. Very dangerous to do. The safety interlock is there for your safety. Discharge high voltage points and components to ground. After you get the equipment turned off, especially tube type equipment, you want to use a grounding wire, hook it to the case, and then put the point of the grounding wire onto the plates of the tubes, various capacitors to discharge them. A capacitor will hold a charge almost indefinitely, and these charges they can hold can be up to 400 volts, so it can do you a lot of damages. These capacitors will store that power even when the power is turned off. So you can turn off your power supply, start to work on it, and if you touch the part of the capacitor, you can get a nice healthy jolt from it. Storage batteries are extremely dangerous when they're shorted out. Now, most of the guys that get into radios are kind of handy around the house. They like doing things. They like working on their cars. And I've seen this happen many times. They'll open the hood of the car. They will take something loose. They'll lay the wrench down on the battery. Now, most of the time, the people will look where they're laying the wrench on the battery so it doesn't short out the positive and negative terminals. But if they would happen to touch those two together, extremely high current draw, which means lots of heat, lots of hydrogen gas manufactured, and of course a spark will cause it to literally explode. Now, if you're responding to an electrical energy, if you'd walk into a room and there's some guy laying on the floor twitching, the very first thing you want to do is, of course, turn the power off, get rid of all the power. In your Radio Shack, all your on-off switches and your circuit breakers, they should be clearly marked. So anyone coming in there can sort of find them. You should install an emergency master power switch and make sure your family knows how to use it. I was in the Navy on board the ship. When I was in the transmitter room, we had one electrical panel that was painted red. It had a single handle on it. And the radioman knew that if they came in there and saw an electronic technician smoking, not cigarettes, but smoking because he got across something, they knew all they had to do is pull that red handle on that red fuse box, and the power would immediately be shut off. You never ever want to grab the person who is currently experiencing an electrical shock, because then you'll get it too. Make sure that power is turned off, and of course you call for help. Another thing you should really do, and not just for since you're getting into radio, but you should learn CPR and first aid. It's good for everything. But these are some of the ways you should and should not respond to electrical energy. Make sure the power is off, then call for help. Grounding, electrical grounding and circuit protection is you want to make sure that your station meets the code. Now, most ham radio equipment does not require special wiring or circuitry. You just plug them into the wall socket. But you want to make sure that you use the 3-wire power cords. Use the circuit breakers, outlets, the ground fault interruptings, or the regular outlets. It's no really special wiring you need, but always use 3-wire cords. You don't overload single outlets. That's at the bottom of the screen down in the red. It says don't overload single outlets or circuitry. Most everybody has seen National Lampoon's Christmas Vacation and the Christmas tree light fiasco. And when Ellen went in to turn on the light switch, there was this humongous bundle of wires where Clark had wired all the Christmas lights into one little receptacle. Hilarious, but you don't want to do that. One plug per receptacle. Grounding and bounding at RF. RF burns are from hot spots. They're because of high RF voltage. A lot of you may have experienced it when you're with your CBs or something. If your CB wasn't tuned quite right, if it had a real high standing wave, you might touch the mic and get a little bit of tingle with it. That is RF coming onto your mic. And you can get an RF burn if it's a strong enough power there. It usually doesn't give you very serious injury at the ham level. But the best thing you can do to prevent that is by bonding all the electrical equipment together. And like I said earlier, most of the electronic equipment in ham radio anymore has got that extra terminal on the back of the radio that is for grounding. You should try to keep people away from your antennas, radio and counterpoise wire. We're going to be dealing with that a little bit more when it comes to RF safety on antennas. And ground equipment for AC safety. All your stuff should be grounded properly. Lightning protection. The stuff we're going to be talking about on lightning protection, it will not prevent a lightning hit. But if you do get hit, it will really mitigate the problems that might turn up with your equipment, damaging your equipment. You should ground all your antennas and towers to the local code. Usually the codes are very vague, but basically you use an 8-foot ground rod for each tower leg. When you do that, you put each of the 3 ground rods by the tower legs. You take a heavy cable and you connect that ground rod to one of the legs on the tower, and then you hook all those 3 ground rods together. Makes you get a really good ground. These ground connections, in fact, there's a test question about this. Ground connections should always be as short as possible. You use lightning arresters. You can buy lightning arresters to put on the ground plate where the cables enter the house. The ground plate is usually a brass plate. Now, most ham radio stations do not have these, but you'll find these in commercial radio stations and stuff. A ground plate where all the coax is hooked up to this ground plate. It passes through. That ground plate is then hooked to the physical ground with a very heavy cable. During lightning storms, the best thing you can do, of course, is just unplug the equipment, disconnect everything, and all the feed lines. Like I said, you cannot stop lightning from hitting, but you can mitigate the damage done by lightning by simply doing some of this stuff, making sure your antenna tower is grounded good, unplug stuff. The nice thing about ham radio is a lot of ham radios get into weather spotting. When severe weather comes through, switch to your walkie-talkie, your handy-talkie if you will, to get into the repeater. That way you can unplug your outside VHF, UHF antennas, HF antennas, and unplug all your station equipment. It's a lot safety. Another thing to talk about would be RF exposure. The electromagnetic radiation is not the same thing as radioactivity. Radioactivity comes from the alpha waves, the beta waves, and the gamma waves coming off of stuff like uranium-237, 238, that kind of stuff. They're dangerous. That kind of radioactivity will hurt your cells. It can kill you, right? It can give you cancer. Electromagnetic radiation is not quite the same. It will heat your body tissues. Hello, microwave ovens, that's what they use. Up in the gigahertz frequency with the right amount of power, and they'll cook your hot dogs in a minute flat. This heating that it'll do on your skin, if you get into this RF energy, it does depend on the intensity, which is how strong the radio wave is, and also the frequency. If precautions are taken, the RF exposure is minimal and it is not dangerous. The one thing about the whole thing is that the average human being is almost a full wave of the 2-meter band, which means that when you're using 2 meters, your antenna will pick up this RF intensity fairly well. But anyway, the RF intensity is basically the power density, how much power is floating around in the air that you're going to be getting into. It's measured in watts per square centimeter. The higher the power density means higher RF exposure. Quite simply, that means the more power you're putting out, the higher the RF exposure you're going to be getting to your body. The RF absorption does depend on the frequency, and that is due to the body part size. Like I said, 2 meters is close to the average height of Americans anymore. So we're a full wave antenna for 2 meters. The safe exposure levels have been established by the FCC. They've got these graphs that will show you all sorts of different maximum power exposures. They graph that along with the frequencies. You'll notice the frequencies on this particular slide, 30 to 300, that's the frequencies that we use. Luckily, it's not that bad on those frequencies as compared to the higher frequencies and even the really low frequencies. When they say RF environment, they are talking about two things. A controlled environment. A controlled environment is when you know where everybody is at, standing around your antenna, and you know you can do something about it. We have this trouble on field days. We'll have all sorts of antennas in all sorts of different arrays and situations. A lot of people walking around looking at the antennas. They can get right up to the antenna. As we'll find out in a little bit, if you're transmitting and they happen to touch the end of that antenna, they can get an RF burn about it, a really bad RF burn. You can put out more power if you're in a controlled environment. The FCC says you can put out more power because you realize there are people out there maybe in harm's way, so you can do something about it. An uncontrolled environment is just the opposite. You have no control over the people near your antenna. Your antenna might be a couple hundred feet away. You might be inside a building where you can't observe people getting close to your antenna. So it's considered an uncontrolled environment. And when it's an uncontrolled environment, you do have to lower your power out there to help keep the people safe. Duty cycle and duty factor. A duty cycle is basically how long your transmitter is on the air. If it's solidly on, or if in the case of Morse code, where it's going off and on, or if it's the case of single sideband, where it's varying all the time. FM, for instance, is 100% duty cycle. That transmitter is putting out full wattage all the time. And the duty cycle factor is the same thing as the duty cycle, but it's just got a lower number you have to deal with for mathematics. The higher the duty cycle means the higher the average power density and exposure. In other words, the more constant your power is being put out by your transmitter, it makes a lot higher power density and exposure. So you got to be a little bit more careful. The different modes have different duty cycles. If you can read this one here on conventional single sideband, 20 to 40%. So of the total amount of power that you're putting out, can put out, only 20 to 40% is on sideband. If you're on digital FM or just regular voice AM, it's 100%. That means if you're transmitting an FM signal, your transmitter is putting out all the power it can all the time. The RF exposure evaluation, all fixed stations must perform an exposure evaluation. I am guessing here, and it's just my personal opinion, probably 2% of ham radio operators have ever done an RF exposure evaluation. Number of reasons for that. Number one, you can use an online calculator. Just this afternoon when I was going through these slides, I went online to check about this online calculator. Easy to use. It asks you what frequency you're on, how much power you're putting out. It asks you the duty cycle, whether it's 100% or maybe 40% or something like this. And it asks the type of antenna you got. And that's all there is to it. And when you plug in those various numbers, then it will tell you what your evaluation is. And then with that evaluation, you can decide whether it's safe or not to be around your antenna and your equipment. There's a model exposure with software. They say it's difficult to use. I've never used it. I've always went to the online calculator because it's always so much easier. You can measure the power density too. It's the most difficult because you do need special equipment to do that. At lower power levels, there's no evaluation required. For instance, at VHF on the 2-meter side, and anything below 50 watts, you don't have to worry about at all. And most of the radios out there, base stations, will only put out 50 watts or less on VHF. Now, if you put a linear on your VHF station and you pump up the power to 1500 watts, then you might want to go online and see, how far, with that exposure evaluation, you can find out how far away you've got to stay, and other people must stay from your antenna so they don't get hurt by it. It also says you're supposed to reevaluate the exposure when you change equipment or operating frequencies change. Some frequencies, it's a lot more dangerous than other frequencies. If you're changing to a higher power equipment, all these will change that exposure evaluation. So you should check that. Now, to reduce RF exposure, a lot of it is really simple. It's just as simple as sometimes just relocating your antennas or reorientating your antennas. For instance, if you've got a directional antenna, you just point it a different direction. It's just that easy. You can raise the antenna up, get it up in the air further away from you. That will reduce the exposure. You can reduce the antenna gain. I don't know if you want to do that because that means you aren't going to talk quite as far. And another iffy thing is reduce the RF power output. Now, amateur radio operators, it's in our mantra that, dogma that we always use the least amount of power to get the job done. We don't want to use more power than what we need. We're just adding static and noise to the air. And it also, when you use the least amount of power, you're reducing your RF exposure. You can change to a lower duty cycle mode. Instead of going FM, you can go to sideband or CW. Mobile safety, and we're going to be talking about mobile installations now. The first one is the big one here. You secure all equipment. You don't go out and buy a mobile 2-meter dual band 2-meter 440 type radio, put a cigarette lighter plug on it, plug it into the cigarette lighter, and then throw the radio on the seat next to you. You mount these things all secure. You had to place the equipment where you can operate it safely while driving. So far, there is some laws that, how can I say it? They limit the use of radios in vehicles, like cell phones, for instance. Most time, the radio operators are exempt from those laws because they know that we're supposed to be a little bit better trained, and we know that, you keep your eyes on the road. The big thing is, though, is when you put that equipment in your vehicle, make sure you can just glance down and look at it to see whatever you need to see, what frequency you're on or whatever, what memory channel. You may need hands-free microphones. This is really the best shot, but you got to understand with a hands-free microphone, you'll probably have to use like a Vox, transmit on your voice signals. This can be bad because if you have your internal radio, your AM/FM radio turned up, it can kick on your transmitter, so you don't want that to happen. And if you got the kids yelling in the back seat, you don't want them kicking on your transmitter either. Power line safety. We definitely want to keep our power lines antennas well away from the power lines. These power lines you see out in towns and out in the country that feed that little round transformer that's up on top of the pole, that power line, some of it's got 13,800 volts on that. So if you get your antenna, you want to keep it well away from it so it won't arc over and get it, because if your antenna hits that power line, that's going to come down your coax and in through your radio and in through your shack, and it's going to cause a lot of damage. And if you're hanging on to something inside the shack, you can get electrocuted. So you definitely want to check for power lines before you install antennas, especially in the trees. It says to provide 10 feet of clearance. That's a minimum of 10 feet. More if you can possibly do it. If your antenna starts to fall, if you're putting up a tower and you've measured it and you're 10 foot away and you get your antenna and tower halfway up, the wind could catch it and drag it into those power lines. So you're definitely 10 feet away. Remember that number. You should never attach guy lines to utility poles or structures. Off on a tangent a little bit, they're called guy lines, G-U-Y. I hear so many people call them guide, G-U-I-D-E. They want you to put guide lines on your towers. They're not called guide lines, they're called guy wires or guy lines. It's just a little pet peeve of mine, so we'll let that go at that. As far as tower work, basic tower safety. You're supposed to, of course, wear the proper clothing, hard hat, eye protection, especially if you're on the ground, because the guy working on top of the tower doesn't necessarily need the hard hat, but if he would drop a nut, drop a screwdriver on you, we're looking at emergency room situations here. You should use a proper climbing harness, not a lineman's belt or rock climbing gear. If you don't have a proper climbing harness, use a belt or use rock climbing gear, because it will protect you. If you would happen to slip or fall, it will keep you up there. It won't let you fall to the ground. and break bones, right? Crank-up towers. A crank-up tower is a great invention. A crank-up tower is virtually a tower that you stand it, you mount it to the ground. There's a little crank at the bottom of it, and you start turning the crank, and that tower starts to telescope up. It can go up 40, 50 foot. You should never climb one of these crank-up towers, though, unless you can block and secure it first. The only thing that holds that tower up in the air is that cable. And if you're on top of that 40-foot crank-up tower, and that cable breaks, you're going to come down really, really fast, and you're going to end up in the 911 again. So make sure you block it and secure it if you have to climb it while it's up. The best thing, though, is to bring the tower down, collapse it down where it's only maybe like 15 foot off the ground. A lot easier to work on your antenna at 15 foot as opposed up at 40, 50 feet when the wind's kind of blowing it. Another neat gadget you'll have to use if you're putting up your own tower is a gin pole. A gin pole is basically just a single pole with a pulley on the top, and the bottom of it you hook to the side of the tower somehow. It's a little bit longer than 10 foot because most tower sections are 10 foot. And what you do to that gin pole is you can lift up these tower sections one at a time. Myself, I put up a 50-foot tower all by myself by using a gin pole. I had the person down on the ground would hook the next new section to the rope, and then I'd pull it right up there. Gin poles are really handy. Make sure, though, that you do have somebody there helping you use a ground crew. If for no other reason, someone has to call 911 in case you screw up there. Practice questions. Which of the following is a safety hazard of these 12-volt storage batteries? And we all know that shorting these terminals can cause burns, fires, explosions, that sudden rush of electrons. Tremendous amount of heat makes a lot of hydrogen gas, and that hydrogen gas can explode. And when I say explode, I mean explode. It doesn't pop like a firecracker, it explodes. What health hazard is presented by electrical current flowing through the body? Well, there's a number of health hazards, actually. First of all, it can cause injuries by heating up the tissues. Your current going through there. Probably in high school, you've done the experiment with the electricity where you stuck a hot dog on both ends with 110 volts, and you can fry the hamburger or fry the hot dog. Same thing happens with your body. When the current starts going through, it starts heating up your body, and actually it starts lowering the resistance, so more current starts to flow. It can disrupt the electrical functions of your cells, stop your cells from working properly. This last thing, it may cause involuntary muscle contractions. This could quite probably save your life. This is what throws you away from equipment. Back in the days of the old televisions, not when we had nice thin ones like this, but we had the big old picture tubes to tremendously high voltage, and there would be technicians accidentally get across from them, and it would almost literally throw them across the room, which is good because it got them off the electricity at least. In the U.S., what is connected to the green wire in a 3-wire electrical plug? The green wire is always the electrical ground. It goes to that screw in the back of the radio, which is hooked up literally to the chassis. The black wire goes to the brass screw on a regular wall receptacle. The black wire is the hot wire. Hot, black, dead. Kind of put that together so you'll always remember it. The white wire is the neutral. It's a return side, and it goes to more of the silver looking screw on a receptacle. And then the receptacle also has that green screw, and that's where the green wire goes to. Now, most power lines you get from local big box stores will have a white wire, a black wire, and then a bare copper wire. This bare copper wire is also the ground wire. What is a good way to guard against electrical shock at your stations? Okay, first of all, you use 3-wire cords and plugs for all your AC equipment. 3-wire cords again. You should have all the electrical receptacles hooked up to 3-wire wiring codes. Should be white, black, and the bare or the green wire. One of the most handiest things you guys can buy for your station is this little gadget here. $4 or $5 at your local big box store, hardware stores. And what you do, you plug this thing into the wall socket, and then the little lights will light up. You want to see 2 green lights light up. If that happens, it means your wiring is safe. If this red light comes on, it means there's something wrong with your wiring. You may not have the ground wire hooked up, the white wire could be open, but basically these little things, these are only like $3, $4, $5. Great for Christmas stocking stuffers, stuff like this. So, and this is good for everybody, not just ham radio operators. Anyone can use these in your house. If all of a sudden your stereo goes out or your TV goes out, you don't know if it's a receptacle, lost power or something, plug this in and it'll tell you immediately if your receptacle is powered up and is wired up rightly. Definitely get one of these little babies. They're really worth it. The circuit ground interrupter by the ground fault interrupters. These are those little electrical outlets that's got the 2 little buttons in the center of them between the 2 actual outlets. One says test and the other one says reset. The circuit is protected by this ground fault. If anything goes wrong with the ground, it will automatically trip, so it shuts off the power to your equipment. With personal experience though, and because I like the old radios, I think real radios glow in the dark, all right? I love working on the old Heathkits and Drake stuff, the tube type radios. And I have found that when I'm working on them, when I'm tuning them, sometimes the RF can get onto your AC because that equipment just wasn't, quite frankly, it wasn't built as good as the stuff nowadays. And it will get on your AC and it will trip a ground fault interrupter. Precautions taken when installing devices for lightning protection. You should mount all the protectors on that metal plate. That is in turn hooked to an external ground rod. So if you want to make your shack really neat, you put a brass plate on the outside, you mount your antenna connectors to it, and your lightning arresters on it, and then that you have a really heavy ground wire going down into one of those 8-foot ground rods. Safety equipment that should always be used in home equipment and home build equipment especially is the fuses or circuit breakers, and that should be on the hot conductor, on the black wire. You want to put the fuse on and on circuit breakers. Now in mobile equipment, you'll want to put fuses in both the red and the black wires. But in home equipment, 110 volt stuff, you just need to put the fuse on the hot conductor, the black wire. What kind of hazard might exist in a power supply when it's turned off and on? Just talked about that a little bit ago. The large capacitors inside of power supplies. These large capacitors, they help filter out that DC that you've created so your radio is getting a nice smooth DC. But these large capacitors, they can hold quite a bit of charge, quite a bit of electrons, and depending on the voltage, they can give you quite a zap if you happen to get across them. So you got to be very careful when you're dealing with capacitors. When should the members of a tower work team wear a hard hat and safety glasses? At all times when work is being done on the tower. Now you notice it says the tower work team. They're talking about the people on the ground here. You should always wear a hard hat and safeties. Some people say that the guy working up on top of the tower should not wear a hard hat because it can distract him. He might bump something, he might start to lose his helmet, and he might quick grab for your helmet, which would be a natural reaction, and you might lose your grip and get into trouble that way. But definitely if you're up on top of the tower, you need a good climbing harness or belt and glasses. You use glasses so that you know, a bolt that comes slipping out doesn't hit you in the eye or anything. But definitely if you're on the ground team, you definitely want to wear a hard hat all the time and safety glasses. What's a good precaution to observe before climbing a tower? You should put on this regular climbing harness, right, and safety glasses. You notice they don't mention a hard hat here, but you definitely want to keep that climbing harness on. You have to put it on no matter what time of the year it is, but definitely don't poo-poo it in the wintertime. You get up on top of a tower in the wintertime, you start getting cold, your hands start losing their grip. You definitely have to have a climbing harness. Under what circumstances it is safe to climb a tower without a helper or an observer? Never. That's a very simple thing, and I think it's obvious. If something would happen to you on the top of the tower, someone is going to have to notify the fire department to bring a ladder truck to get you down. Which of the following is important safety precautions to observe when putting up in a tower? And that is, you want to make sure you are clear of all overhead electrical wires. That tower is a great conductor, and it will bring that 13,800 volts right down through you so quick. The purpose of a gin pole, the gin pole is a tool. It is to lift the tower sections or antennas up to the top of the antenna. It's usually, like I said, a pole. It's a little bit longer than 10 foot. It's got a pulley with a rope through it, and that's how you get the sections up there. A lot of people will assemble their tower on the ground, including the antennas on the ground, and then they get a crane come in and they'll set the whole thing up at once. This is really the easiest way of doing it. Minimum safe distance for a power line, we all know 10 feet. And 10 feet is the minimum. You want even more if at all possible, because you never know how that wind is going to catch a falling antenna. And an important safety rule when using that crank-up tower, you should never climb it unless you've got those safety locking devices installed on it. And a safety locking device, I've seen some just as simple as a 4x4 piece of wood stuck between the three legs, so it just simply can't physically come down. The best thing, of course, is retract the antenna and work on your antenna when it's close to the ground, and then crank the tower back up. What is considered to be a good proper grounding method for an antenna? 8-foot ground rods, you can get 10-foot ones if you want. 8-foot ones is about the minimum you want to do. You put one for each leg, and then you bond it to each leg. And by bond it, that means you run a nice heavy copper wire from the ground rod to the tower leg. And then you bond, or you wire each one of those 3 8-foot ground rods together, so they're all at the same identical potential. Some ground rods you might be at the same tower site, you might be going down into sand. Another you might be going down into dirt. So they have a little bit of difference of resistance there, and that can cause big troubles. But anyway, yeah, you want 3 of them on each leg of the tower. Why should you avoid attaching an antenna to a utility pole? Quite simple. That antenna could very easily come in contact with those high voltage lines, and you don't want that. What is true concerning the grounding conductors used for a lightning protection? Sharp bends must be avoided. Now what they're talking kind of about here is, like if you're running a wire from your tower leg out to your ground stake, you don't put a sharp bend in that wire going out to the ground stake. You want it straight. The reason it catches a lot of people off guard, that sharp bend can act like a fuse. It can actually blow apart if there is a lightning strike, and if it blows that bend apart, then you're losing all your lightning protection. So you want a straight wire from the tower leg out to the ground rod. Which of the following establishes grounding requirements for an amateur radio station or antenna? It's local electrical codes. And most of the time, you won't have any trouble with these local electrical codes. Now, you may have trouble with the city or your homeowners association saying you can't put up a tower. As a radio operator, you are allowed to put up radio towers. Now, they don't want you to put up, 200-foot tall towers, but they must allow you to put up a tower that you feel will be sufficient for the work you want to do. But with the local electrical codes, they will tell you, use an 8-foot ground rod, things like that. Which is the following is a good practice when installing the ground rods for lightning protection? You make sure that all the connections are short and direct. No bends, no right angles. You want them short and direct. And what type of radiation are VHF and UHF radio signals? These are non-ionizing radiation, as opposed to ionizing radiation like gamma rays and stuff like that. So these radio waves, they won't give you cancer or anything like that. But if you touch them, get close enough to them, they can start heating your skin. Maximum power level that an amateur radio station may have for VHF frequencies. This is one of the questions that's drawn on the test pool. It is 50 watts at the antenna. Now, 50 watts at the antenna, let's think about that. If you've got a 3 dB loss in your coax, 3 dB loss means you've cut the power in half. That means if you have a 100-watt station, VHF base station, and a 3 dB loss on your coax, up at the antenna where they measure this, you'll only have 50 watts of power. So that's about the 3 dB. I'll go over that a little bit again. It kind of confuses people. Plus 3 dB means you're doubled your power. A minus 3 dB means you've cut your power in half. And this is an example of it where you can have a 100-watt station. Now, if you have your 100-watt VHF station and you're using hardline, which has very little impedance to it, then up at the top, then it may be a lot more than 50 watts. Then you'd have to watch your RF exposure. But normally, 50 watts at the antenna, and you should not have any trouble, unless you're running a big linear or something. What are the different factors that affects the RF exposure of people near the amateur radio station? Well, of course, it's the frequency and the power level. How much power your radio is pumping out and the frequency it's pumping out. Like if you're on 2 meters, you know, you want to keep people away from, further away than if you were on HF, because at 2 meters, you're about a full wavelength, and your body can absorb this power a whole lot easier, which you don't want. The distance from the antenna to the person. You keep people away from your antenna. And of course, the radiation pattern of the antenna. If you've got a beam antenna, you don't want to point it at people. Why do the exposure limits vary with frequency? Well, it's because the human body absorbs more RF energy at some frequencies than other. And like I said, with us, the 2 meter band, we are pretty good receptacles of this RF energy, so you do have to be a little bit more aware of it when you're using VHF. Now there's a bunch of different methods. We talked about that just a little while ago about how you can figure out what your RF exposure is. One of them is based on the FCC Bulletin 65. Another is calculator based on a computer modeling, or by measurement of a field strength using calibrated equipment. The best way, though, is using an online app that will just, you just fill in the blank, fill up how much power, your frequency, your type of antenna, and then that will give you your exposure readings. What would happen if a person accidentally touched your antenna while you were transmitting? Well, he might cuss at you because he's going to get a really bad RF burn if you didn't warn him about it. And let me tell you something about RF burns. You know, you can put your finger on a lit match and it'll burn your skin and it'll hurt. After a couple days, it goes away. RF burns are different. RF burns burn deep. They go clean to the bone, and it takes weeks for that burn to actually heal itself. So that's what happens. That's why you want to keep people away from your antenna, right? That is a controlled environment if you know where the people are at, so you can warn them to stay away from that end of that antenna. Which of the actions might a ham radio operator do to prevent this radiation in excess of the limits? Basically, you just relocate the antenna. It could be like, especially if you're on the ground low down, you might put it up higher, point it in a different direction. You just relocate the antenna. That's all you got to do. How do you make sure your station stays in compliance? Because you're supposed to reevaluate your station every time a piece of equipment is changed. You might have bought a larger radio, a more complex radio that puts out more power. You want to reevaluate to make sure that your RF exposure is within limits. The duty cycle. Why is the duty cycle one of the factors used to determine a safe exposure level? Because it affects the exposure of people to radiation. There again, if you're transmitting FM, CW is turning off and on. So that's one of the ways why you want to know what the duty cycle of your particular mode of operation is. And the definition of that duty cycle is the percentage of time that the transmitter is transmitting. You may be on the air, it might be your turn to talk. And if you're using CW, you are turning off and on your transmitter, so it's not on 100% of the time, like it is when you're using FM. How does the RF radiation differ from ionizing radiation, radioactivity? The RF radiation does not have sufficient energy to cause genetic damage, where if you get around radiation from like uranium-237 or something like that, yeah, it can give you cancer. The RF radiation that you're going to be dealing with in your shack does not do that. Kind of complex question. It's really easy though. If the averaging time for exposure is 6 minutes, in other words, you're going to be on the air for 6 minutes. How much is this power density is permitted if the signal is there only for 3 minutes and absent for 3 minutes? Well, it's twice as much. So if you're just on there half the time, you can use twice the amount of power. It all works out the same. This question is on some of the questions I've seen, on some of the tests I've seen, because they do want you to know that you do have to be careful with this power intensity. And that's the end of Module 9. We're going to go right into now 9B. 9B is all about radio interference. Radio interference is interesting because you could be the cause of radio interference, and people can be interfering with your radio, with their stuff. And we'll be talking about that, the difference tonight, and different ways that we have to treat radio interference. And it's just about loaded. Here we go. Radio interference, RFI. Signals that interfere with radio receptions. Now, you can't be focused in on this. Signals that interfere with any kind of radio reception. You may be interfering with your neighbor's television reception or his FM radio reception. They might be interfering with your radio reception. It can be either from your station, interfering with somebody, or to your station. And solving the problem might take a little bit of detective work too. One simple thing is a lot of times a friend of mine was having static trouble in his radios. Come to find out his electrical line outside had a bad insulator on it. He found it quite simply. He took his walkie-talkie out without the antenna, and when he got close to that power line, the static really picked up. So he knew that was something in that power line was wrong. He called the power company, and they came right out and fixed it. But sometimes you do have to hunt for it, and sometimes it can be pretty well hidden. There's been cases of the dimmers, light dimmers on your house lights. They can cause interference in your reception too. So there are different types of RFI. One of them is direct detection. And that means the offending signals, they go right into your circuits. Now it can be because somebody's got a transmitter right next to you and they're transmitting and that RF power gets right into your circuitry. It can also be because of overload, strong signals that just overload the receiver to reject it. RF current can be picked up by cables of consumer equipment. Basically what this would be was you interfering with somebody else. When you transmit, those electromagnetic waves could be cutting through their cables, their power cables and stuff, and it could be causing them interference. Transmitted harmonics must be filtered out at the transmitter. Nowadays with the new equipment you won't have hardly any trouble with transmitting harmonics. But if you're old school ham and you got the old tube type stuff where you have to constantly tune it, you can transmit harmonics. That's a double frequency. If you're on like 7.2 megahertz, if you got a harmonic, it might be putting it out at 14.4 megahertz, which is also in the ham band. So you can be putting out harmonics. You have to filter that out at the transmitter with better tuning or actual better filtering circuitry. Filters. We went over filters several weeks ago. Filters attenuate signals. They reduce signals. There is a high-pass filter. It stops lower frequencies from getting through, but lets the higher frequencies through. When you buy a high-pass or a low-pass filter, you'll have to see what it's cut for. For instance, the low-pass is what ham radio operators use on our equipment if we're interfering with people's televisions, because our frequencies are lower than the television frequencies. So we want a low-pass filter to let our frequencies get up to the antenna, but if we've got any high frequency components of that signal, it will block it out. High pass usually gets put on the receiver that's getting the interference. Back in the day when, in the old style television systems, you put a little high pass filter on the back of your TV. That would keep CBers and ham radio operators from interfering. Those were high pass. It let those higher television frequencies through, but it would block or reduce the low frequencies. And then there's the band pass filter. The band pass, it only passes a range of signals. Now, if you're on a band and you're operating between these two frequencies, and there's all sorts of ham radio operators on here, they're all going to be interfering. If you put a band pass filter in there, you can close it down a little bit, so you're just receiving a narrower range of those frequencies, and you're getting rid of the others. There's other types of band pass where it eliminates a totally different radio band of frequencies. The notch filter is a band pass type filter, but it's very, very narrow. If you're operating on the 10-meter band and there is someone right next to you transmitting, he might be putting just a dead carrier on the air because he's just trying to tune up something. A notch filter, you can move that right over his frequency and it will block his very narrow signal out, where you can still hear people on both sides. You can tune up and down and hear him, but it will block his transmitting out. And remember, you don't really want to tune on the air. You will have to at times when you're actually checking your antenna, but if you're just tuning your radios and making sure everything's putting out power, use a dummy load. So you do have to get the correct signal, or the correct filter, excuse me, and it does understand the source of the interference, whether you have to put a filter on your radio to stop interfering with them, or whether you have to put a filter on your radio so they stop interfering with you. Ferrite chokes, made of iron. They're basically, most of them look like little donuts made out of graphite. And it opposes AC, RF on cables and wires. It can block that RF current that causes interference to entertaining equipment. For instance, you might be transmitting and someone next door might be practicing his guitar amplifier or something. Your signals could be going right into his either audio cables or AC cables. You could put a little ferrite coil on it, and that would block you from interfering. A lot of the times anymore on the little chargers you see for cordless or for cell phones, they've got a little round thing on the end of them, all covered up. That's a ferrite to keep RF off of it. You wind the cable through this ferrite core to create the blocking impedance, and it's just that simple. You got the little round coil, you just take your wire and you just loop it through a couple times, and that way any RF that's on the outside of that cable will get blocked by that ferrite coil. Cable TV interference. A lot of the times with cable TV interference, it'll be because of VHF. Here in our town, our local repeater, which operates on 146.895, it can get into channel 22 of one of our local cable providers. If it does, it is usually because the cable TV is at fault. They have either got broken shielding, they might have loose connections, broken connections, but more than likely they've got corrosion. The connectors have been out in the weather up on top of the pole. They get corrosion. Corrosion makes a little bit of resistance, and that little bit of resistance can really pick up the signals and get it in on their cable TV interference. So corrosion, corroded connections in cable TV is usually the main cause of ham radio operators interfering with cable TV. And it's usually solved by just a proper cable maintenance by the cable supplier. They should come around, and clean up all their connections on the poles and everything, and the connections down to your house. Rarely happens, but they should be doing that kind of preventive maintenance on it. There's all sorts of noises that can interfere, cause interference. Electrical arcs, like from motors, electrostatic, electrostats, thermostats, electric fences, neon signs, light dimmers. These are all sources of noise, and this is where it takes the detective work to find out where that noise is coming from. Power lines, like I said, insulators on power lines can cause static. And I will tell you from experience that the power companies are very good about coming out to clean up any noise on power lines. Motor vehicle ignitions and alternators. When you've got a mobile radio in there, you can hear that pecking sound. That is your plugs. That's the high voltage going to your plugs making that sound. If you've got a whine, that is usually coming from your alternator. So either one of those, you should do some maintenance on your vehicle. The alternator whine, it can be virtually eliminated by a simple little choke that you put in line with the 12-volt line coming to you. Switching power supplies, they can put out a lot of noise. Nowadays, the switching power supplies that are made, like I said, we've advanced so much in electronic design. Most of the power supplies you can identify with, they're the big boxes and they're heavy. They've got this big transformer in them. Well, switching power supplies, it's about the size of this laptop that I've got in front of me. They bring the 110 volts down through 12 volts through a switching system. And those switching systems, the circuits inside, they can do a lot of noise, generate a lot of noise. But you don't really have that much trouble anymore. Computers, networks, and TV sets. Two-way street on those. You may have a computer that's putting noise into your set, or your set could be putting it into the noise. TV sets, they themselves usually don't put out noise, but they are very receptible to noise. The TV picture is an AM signal, and AM is very susceptible to interference. Some RFI guidelines, radio frequency guidelines. First of all, if you just operate your equipment properly, if you've got it grounded right, if you've got a good low standing wave, everything's tuned up right, you will never have any trouble. You'll want to eliminate the interference in your own home. Your house will put out some interference, and you want to eliminate it in your own home so you can hear those weak signals just a little bit better. So you use good station building practices to eliminate those unwanted signals. Like I said, you make sure everything's grounded, everything's tuned in good. Use shielded wire or cables will help do it. And you should also use shielded equipment. A lot of the equipment nowadays are made up of plastic or composite plastic stuff. The older ones had metal, so we didn't have too much trouble. But nowadays, the equipment isn't that shielded as well as it could be, so you do have to be very aware of the shielded equipment problems. Good connections and filters. There again, you want to get the right filter for the right problem, and you must have good connections. All your connections must be solid. That's why up on your antenna, when you screw your antenna into your coax, we want you to seal it up good, tape it up good so moisture doesn't get into it, so you don't get that corrosion. Dealing with RFI. This is where it really takes a lot of finesse on your part, because you should take this interference complaint seriously, and usually it's coming from your neighbors. So you got to make sure that you're not the cause of it. You should demonstrate to yourself first that you are not interfering in your own home. If you're causing interference on his TV, and if it's your fault, you will be causing interference on your own TV. And so you know then that if you're not on your own TV, it's his television. It doesn't have good filtering. And you need a high-pass filter to put on it to keep your lower frequencies out of his TV where he can still get his television signals in there. You should offer to help eliminate RFI even if you're not at fault. This is just being a good neighbor. You're a ham radio operator. They will expect you to know everything there is to know about electronics. They'll probably be, when they find out you've got a technician class license, they'll be dragging over their old VCRs for you to repair. But you have to understand, you do have to help them in any way you can. It's just good being a good neighbor. Consult the ARRL. They've got an RFI resources that is fantastic. You can go online. You can even call ARRL, and they will help you online eliminate some of these RFI problems, especially if there's neighbors involved. Part 15 rules. You know, we all know that Part 97 covers ham radio, Part 95 is CB radios. Part 15 applies only to unlicensed devices. Now, an unlicensed devices may interfere. An unlicensed device is like maybe your remote control for your garage door opener, your TV remote control. Anything that transmits that you don't need a license for is covered under Part 15 rules. They cannot interfere with any licensed service, including ham radio operators. So if someone has a device, let's say it's a garage door opener and it's for some reason it's screwing up, if they're interfering with the business band radios, amateur radios, they are responsible to get rid of it. They cannot interfere with any other radio service. The Part 95 or the Part 15s, these unlicensed devices, they must accept interference from a licensed service. In other words, if your friend complains that when every time you get on the radio his garage door goes up, well, that's not your problem, it's his problem. It's unlicensed devices. They must take all the interference because they're unlicensed. There's no really good parameters made for them. The RFI to and from unlicensed devices is the responsibility of the users of these devices. So, what the rules say is, bottom line, if your station is operating properly, you are protected against all interference complaints. If you're operating right and you can prove to them or yourself that you're operating good, they cannot continue to complain. They can complain to the FCC. FCC won't do anything about it because they know that the FCC knows that it's probably a Part 15 device that's interfering with everything. So, but you should be a good neighbor. There again, be a good neighbor. They might not be familiar with the fact that Part 95 rules and regulations say that their Part 15 transmitter is not protected from interference, or the Part 15 receiver is not guaranteed interference from other radio sources. Now, electrical safety and grounding, circuit protection at the home. Make sure your home is up to code. Get this little jewel. You can go around to your house, plug this into every electrical outlet you got. 2 green lights should appear. That means your wiring is correct. It means your ground wire is hooked up right, your neutral wire is hooked up right, and your hot wire is hooked up right. It's also good too if something just all of a sudden quits working, you can grab this thing, you can plug it into that light socket, and you'll find out if it's the power source bad or if it's something on the equipment is bad. Like I said, this is one of the first pieces of equipment you should get for your ham shack. Make sure that it helps make sure your house is up to code. Most ham equipment does not require special wiring or circuits. Some of your amplifiers may require 220 volts. Some may require 440, for goodness sakes. But most of the time, it's just regular old 110 volt, plug it into the wall socket circuitry. You don't have to worry about it too much. Definitely use 3-wire power cords. And again, if you've never messed with it too much, that black wire, if you're wiring up like a wall socket or something, the black wire goes to the brass screw, the white wire goes to that silver screw, and then the bare ground wire, or if it's got a green jacket on it, it will go to the green screw on a receptacle. Definitely use those 3 wires. And definitely you want to use all these circuit breakers, fuses, ground fault interrupters. The ground fault interrupters, you should also use the ground fault interrupters. You should also use a proper size fuse or circuit breaker size. You never replace a fuse with a higher valued or higher rated fuse. In other words, if your radio takes a 4-amp fuse, put a 4-amp fuse in it. Now, I'll say, yeah, you might sneak by and put a 5-amp in there, but you definitely don't put a 20-amp fuse in it. You keep the proper size fuse. You don't overload the single outlets, like they did in that National Lampoon's Christmas Vacation. I still laugh every time I see that. I think it's so hilarious. Someone would actually put that many electrical plug-ins on one socket. RF grounding. It's not the same as AC safety grounding. We're not talking about that copper wire, the ground wire. We're talking about actually a bonding is a better thing, because basically we want to keep all the equipment at the same RF level. Now the way you do that is you hook all your RF grounds together. That screws on the back of your set that says RF ground on it. Okay, your other stuff, your SWR meter might have it, your linear might have it. You want to hook all of those together because you want the same resistance, the same impedance. So it doesn't have the, you get that RF feedback through it all. So you want to keep all your equipment grounded together at the same ground spot. It does minimize hot spots too. If you don't have your SWR grounded to the same ground that you've got your radio hooked onto, you might touch your SWR meter, you might get a little bit of tingle. Prime indication you need to ground that case. You use a solid strap or wire for the best RF connections. A solid strap and wire is best, as opposed to, it's really hard to explain why. A solid strap is better, it's lower impedance, or a wire or solid wire is for the best RF connection. Now if you use braided wire, which most people end up using, braided wires can cause you a little bit of trouble, because two wires laying next to each other is a capacitor basically, and that can cause some RF connections and RF interference. But basically here you want to use the solid strap or solid wire for the best RF connection. So some of the questions you're going to be running into. What would cause an AM or FM radio to receive amateur radio transmissions unintentionally? It's because that receiver is unable to reject strong signals outside the AM/FM band. This is your neighbor saying that he is receiving your amateur transmission through his AM/FM radio. It means he's got a cheap AM/FM radio that didn't have good filters built into the circuitry. And there again, you'll have to put a filter on his radio. Which of the following can cause ham radio interference? There's several of them. Harmonic overload. You just got a strong signal. It's basically a harmonic overload. It means you've got a very strong signal. Harmonics, it means you may have an older radio, it's not tuned right, and it's putting out all these different frequencies and multiples, which will interfere in other radio services. Spurious emissions is just a random frequency emissions that's coming out. It could be from a oscillator, or it could be anything like that. It's just a rogue emission. The best way to reduce interference or eliminate interference to a nearby telephone is to put an RF filter on a telephone. We really don't have that much problem anymore. 20 years ago, when they had the first cordless phones came out, they operated on around 47 megahertz. They had the little antenna up on it. Yeah, you could interfere with those things, and you had to put a little filter on the line to keep your RF out of these things. But nowadays, all the cell phones we've got, and even the wired telephones we've got, are very well made stuff, so you really don't have that much interference. But if you do run into the interference, you have to put the filter onto the receiver, the telephone in this case. How can an overload of non-amateur radio signals or TV receivers by an amateur signal be reduced? You need to block the signal at the receiver. You have to put that high-pass filter on the TV set to get rid of it. You don't have to put it on your radio. My radio at home, I have a low-pass filter on it. I leave in line all the time. I'm just making darn certain that I'm keeping my signals within the band. Which of the following actions would you take if your neighbor calls you that your station's transmitting is interfering with their radio and TV receptions? This might take some real diplomacy on your part, but you have to, first thing you want to do is make sure your station is operating right. And if you're interfering on his television station 10, turn your station, your TV in your house to 10, and you start transmitting. If you're not interfering on your TV, you're not interfering on his TV. Basically, it means that his TV doesn't have proper filtering built in when it was designed, and you need to put a high-pass filter on it, on his receiver. Which of the following can reduce overload to a VHF transmitter from a nearby FM broadcast station? A band reject filter. Basically, you're putting this filter can be on the inside of your radio, it can be an add-on, it can be on the outside, but basically it is blocking everything outside your VHF frequencies that you want to listen to. You want to listen to 144 to 148 on VHF, it just allows 144 to 148 into your radio, so this nearby FM station won't be interfering with you. Now, what should you do if something from your neighbor's home is harmful interference to your amateur station? Okay, now this can make good neighbors, it can make bad neighbors. You've got to work with your neighbor to identify the offending device. He maybe doesn't realize that he's got electrical problems in his wiring in his house. You can find it for him and you might save his house. He might have a loose neutral wire somewhere that's sparking and arcing. You should politely inform your neighbor about the rules that prohibit the use of devices which called interference. That is that Part 15 device we're going to go over in just a little bit with another question. A Part 15 device is any kind of a transmitter that no one had to get a license for. Remote controls, that kind of thing. And if he's got a remote control that's interfering with your station, he must eliminate the interference. It's not up to you. And you should check to make sure your station meets the standard of good amateur practice. That means, you know, being in tune, not overpower, not putting out a sloppy signal or anything like that. You should make sure your station is working right. The Part 15 device, it is any unlicensed device that may emit low-powered radio signals on frequencies used by a licensed service. Just because your remote control hooks up to your TV and you change frequencies with it, the frequency it used to get to your TV can vary a lot. They use a lot of different frequencies. At one time, remote controls could trigger traffic lights. Some fire departments have little transmitters on their trucks that they flick on and it will turn all the lights red at an intersection so they can get through. Some people found out that certain unlicensed devices, Part 15 devices, could actually trip those lights and turn them red. Symptom of RF feedback in a transmitter or a receiver. It's reports of garbled, distorted, or unintelligible transmissions. RF feedback in a transmitter could be on your mic cord that's causing it to garble. It can be if you're using a handheld inside a building, and if you're standing with your handheld close to a metal cabinet or something, that signal can bounce right back into inside your radio. It won't even come in through your antenna. It will go right in through the case, and it will start garbling and distorting your transmissions. So if someone tells you something wrong with your signal, especially on 2 meters, you might check where you're at. You might be getting some RF feedback right inside it, inside the actual case of your radio. What is the first step to resolve cable TV interference from your ham radio station? You make sure that all the cable coax connectors are installed properly. We know that our ham radio connectors will be installed properly because we want it done right. So we know it's undoubtedly not us, it's those darn TV connectors. You can buy TV connectors, they're called F59 fittings that you can put on yourself. Most people put it on by trial and error and they don't get it grounded good. So a lot of the times it is just the connectors that's causing all the trouble. What kind of hazard might exist if a power supply, when it is turned off and then disconnected? Well, if you're messing with it, you could get a very hard electrical shock with those large capacitors discharging through you. So make sure that if you're working on a power supply, the power supplies will have the largest capacitors that will hold the most current. Regular radios don't have that big of ones. And if they do, they're not that high of voltage. But power supplies especially. If you're going to work on a power supply, taking the case off a power supply or everything, you make sure it's unplugged. And then you go through with a ground wire, a ground jumper, and you want to ground out those capacitors so you don't get shocked. As far as batteries, we know that if you have a lead acid battery, like a car battery, and if it's discharged or charged too quickly, it can overheat. When it overheats, It can give off that flammable gas, hydrogen, and it can explode. So, we are at the end. A few things we want to go over before you turn me off here. Number one, we hope everyone gets their license. We were planning on having the test. This is April 2nd right now, 2020, depending on when you see this thing. We were planning on Thursday. We were planning on doing the testing next Thursday. However, yesterday we found out that here in Effingham County, Illinois, we've got our first COVID-19 victim. So we decided to put off the ham testing. Also, the governor is telling everybody we should stay home. So we are putting off the test until May 3rd of 2020. That's a Sunday afternoon at 2 o'clock. If you're watching this, and if you've been getting emails from me, you are signed up for the test. If you're watching this, and I don't know about you, we might not have a test prepared for you. We've got a lot of people coming in to take tests. We do think we've got enough VE, so it goes pretty smoothly. But if you are planning on coming in and testing on Sunday, May 3rd at 2 p.m., please let us know somehow. You can find out information on Facebook. Leave us messages like that to the club's Facebook page. Having said that, I want to wish everyone the best of luck. You've got 4 weeks to go over these questions and answers. Read the question and then read the correct answer only. The reason you do this is if you ever get stumped on a question during the test, if you take your first guesstimate at it, it's usually the right one because that's the one you've read the most. So study real hard. We've had several guys have already said they're going after general. They're taking their technician class. They're certain they can pass it because they've been doing really well on the online practice quizzes. And they are now studying for the general class. So they'll be taking 2 tests on May 3rd, which is really great, the technician and then the general class. And I wish them all the best of luck. So, having said that, I want to thank some people. I do want to thank the National Trail Amateur Radio Club. We've been doing something very unique the last 2 years. The club has been buying these radio courses, manuals from ARRL. And then we've been supplying them to the students free of charge. We loan it to them. When they come take the test, they have to turn it back in, of course. And we also give them the opportunity just to buy it outright. And they do get it at a reduced level because we get them at a reduced level because of the quantities we buy. But I do want to thank the National Trail Amateur Radio Club for their financial support in this effort because we have bought, oh gosh, in the last 2 years, we bought well over 20 manuals now. And so we're really well set up, and it's really great when we can, help people get into amateur radio as cheaply as they possibly can. Other people I want to thank. I want to thank Byron, AC9AP. He's been our moral support here. Doug, KC9VFI. He was one of the instructors. And above all, I want to thank our producer, Ben, KD9LJF. Ben is the guy behind the camera. He set up all this internet stuff. I certainly couldn't have done it. And I really want to thank you, Ben, for doing this. And I also want to thank the Study Shop / I Help You business for letting us use their facilities here. It's really nice using it. We've got plenty of room here, plenty of chairs, and it's, I can't thank the Study Shop too much for this and what they've been doing for us. So having said that, I want to thank you for watching. I hope you have good luck on your ham radio test. Study hard. You will get the job done, and then you can join us on the airwaves. It is a lot of fun. 73, everybody.